Okay, so today we're going to be graphing sine, cos, and tan, and we're also going to be doing some transformations of trigonometric functions or sinusoidal functions. I'm going to give you some background knowledge would be helpful, but it's not necessary because we're going to start off with easier questions and go into the harder questions. But I'm going to give you a background of the graphing formula and what each variable means and how to use them and how to apply it to questions. So we have our graphing trigonometric functions. So we have sine. Let me use our lightsaber tool. We have sine, we have cos, and we have tan. So I'm going to give you a moment to write these down. So pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees, and 2 pi is 360 degrees if you would prefer to do it in degrees. I normally stick to radians because that's what we normally use, but we can go back and forth. And then we have the graphing formula, and that's just pictured at the bottom, and we're going to get into what each of the variables mean. Okay. So we have y equals a, brackets, sine, cos, or tan, bracket again, k, bracket again, theta minus p, bracket, bracket, plus q. So a is a vertical stretch or compression, or a reflection in the x-axis if it is negative. K is a horizontal stretch or compression by 1 over k. So we're going to go against our instincts here, and we're going to flip the k value to be the reciprocal. So if it's a 2, it's actually going to be a compression by half. If it's a half, it's actually going to be a horizontal stretch by 2, if that makes sense. And it's also, if k is negative, we're going to reflect in the y-axis. P moves left or right. Again, we're going against our instincts here. When we take it out of the bracket and switch the sign, it'll tell you which direction to move it in. Again, I'll repeat that. If you take the P out of the bracket and switch the operational sign, it will tell you which direction to move it in. But I have them written down right there. If it's a plus sign, you're moving left, or a right sign, a minus sign, you're moving right. And Q moves up and down. And that is self-explanatory because plus means up and minus means down. So let's do a few practice questions to understand what this really means and how to apply it to our graphing questions and transformations. We're going to start off easy, and then we're going to get to a bit harder questions in which they have every variable, and some questions only have a few variables to apply to. So we're going to have two options here. We can do a list or a chart. Normally we're going to do both, but for question 2, we're just going to do a list. And let's begin. Sorry, I'm going to switch out of blue here. I see A, which is a vertical stretch or compression or reflection in the x-axis, and I see it is a 2, so it's going to be a vertical stretch by 2. And then I see a plus 5, and we're going to go up 5. And then we have a chart. Sorry, I have something in my eye here. We have theta, we have sine theta, or y, and then we have times 2 plus 5. So we have 0, pi over 2, pi, 3 pi over 2, or 2 pi. 0, 1, 0, negative 1, 0. Okay, so let's begin. We're going to start with a graph. I should have made this before. I'm so sorry. Don't forget to label your y and x axes. And to have a properly labeled scale. It's very important in graphing. I know it looks a little wonky, but it's just because for the x-axis and how I spaced out the radians, in our transformation, so we have the y values, the transformed y values, so these were the original y values, and these are the transformed y values. And because we didn't have k or p, we don't need this space in the chart yet, but we're going to get to that. Oh my god, sorry about that. And we're just going to label them here. I always like showing the original graph, and then sometimes you can show the transformation in steps, like you can space it out or do them individually and then have a final graph. And then the final graph, you definitely have to label that as your final transformation or your final graph or whatever have you. But I just want to do all the transformations at once because I feel like that's more clear and we won't have so many lines going in the graphs. And it can look cool, but I just don't want to confuse you or any of that, or have you have any issues. But maybe I'll make another video and we'll do more transformations. Maybe when I do advanced functions for grade 11. So we have A, which is a half, and that isn't 1 over k or 1 over a. It's not that. It's just how it is. It's a half, so it's a vertical compression by half. A is half, so it's a vertical compression by half. And then I have 2, which is 1 over k, which means the reciprocal of that is going to be half. So it's actually a horizontal compression by half. And for this one, we aren't going to do a chart. I just don't feel like it's necessary, and I really don't want to do a chart. So we're just going to do the checklist. And I'll go back and I'll do a check there. I forgot to check it off. And time to start the graph. Hold on, let me go back here. Am I missing anything? I don't think so. So because we're doing a horizontal compression by half, I spaced it in 2, and we don't need that much of the graph here, so I'm going to use the precision eraser and I'm going to erase some of it, if that's okay with you. So we're just going to, we have horizontal compression by half, so I did 2, so it's going to be easier when we do the horizontal compression. And I also did the vertical compression by half, so I left that as 2 as well. When you're working with sinusoidal functions or trigonometric functions or sine, cos, tan, whatever have you, and you're noticing that you have to shift, like do a phase shift, vertical shift, compression, stretch, whatever, it's important that you space the boxes out in an adequate way. Like if I left it just one box, it would be so tight and compressed and I wouldn't be able to see anything. Actually, I should have stretched this much further if you wanted to see. And depending on the scale, it's going to make the graph look different, but that's okay because it could also be correct. So it doesn't really matter as long as the scale is correct and it's not any like mistakes in it. And also double check your scales, double check your X and Y axis is labeled, and double check your graph when you're done. That's a good way to make sure to ensure accuracy. And I have a tip for exams. Do every question twice. And if you have a letter of recommendations, you might be able to get extra time to do every question twice, or at least do it once and review it afterwards. Review the math and make sure that there are no mistakes. Or for tests as well, just a tip of the trade. So we're going to do a sine, cos function, sorry. Okay, so we're going to compress it by half. And then we're going to label as well. You see how it's compressed vertically and horizontally and how tiny it is? That's what it should look like. Okay, check and check, and we're moving on. So I just got my lesson plans out here. Okay, it's gonna get a bit more complicated, but that's okay. I'm gonna walk you through, remember here how we had this column that we didn't use? We're gonna use that column right now because we have a phase shift, aka P, moving it left or right. That's what a phase shift is. And a vertical shift is self-explanatory. Oh, I see a 3. A is 3, so it's going to be a vertical stretch by 3. We're going to go back to take it out. It becomes a plus sign, switch the operational sign, plus, moving up the graph, so you're going to move it right. and we're going up 1. And time for the chart. Okay, so we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then we have 0, 1, 0, negative 1, and 0. 1, 1, 1 for the zeros, and then we have a 4, and we have negative 2. And then for plus pi over 4, 0 is just pi over 4, and so when you're adding pi over 4, you just have to create common denominators with all of these. Let me get my lightsaber tool, common denominators, and then you can add them. So if you want to do that on your own, I'll give you a moment to pause the video. Moving on, 3 pi over 4, 5 pi over 4, and I think 7 pi over 4. Moving up because I need to space it correctly. Okay, so we have our chart. So these are our new values for our x values, or our x-axis. And then these are our new y values. So those are the transformations. If you want to write them down. And let's do a graph. Okay, so I see a lot of pi over 4 is 45 degrees, pi over 2 is 90 degrees, 3 pi over 4 is 90 plus 45, 135 degrees, pi is 180 degrees, and I'm not going to do the rest, but I know it's increments of 45 degrees, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I have enough space. So you're just counting by 45 degrees, but in radians. Okay, so we're going to do a regular sine graph, and then we're going to do our transformations as well. And I'm wondering if I go up to 4, so 1, 2, 3, 4, I can go up to 5, that's perfect. 1, negative 1, negative 2, and I go down to negative 2 as well. Okay, it's sine, so we're starting from 0, and then pi over 2, pi, 3 pi over 2, oh, never mind. There you go. We have one more question, and it's the most challenging, but I promise to explain the best that I can. Again, we have our new x values and our new y values. So those are transformations. You just gotta find where to put them. So we have 1 and pi over 4. We have 3 pi over 4 and 4. We have 5 pi over 4 and 1. We have 7 pi over 4 and 2. And we have 9 pi over 4 and 0. Oh, I mean 1, I'm sorry. Sorry, I'm used to the original sine function. That's what I was saying there. Okay, and then we have y equals sine theta. And then we have y equals 3 sine theta minus pi over 4 plus 1. So you see how we have a regular function, sine theta, and then, or a base function, if you will, and then we have all of our transformations layered into one function as well. Okay, moving on. Oh, I'll give you a minute to write that down or catch up. You can pause the video, and I'll get a drink of water. Okay. We have a vertical stretch by 4, because A is vertical stretch or compression or reflection in the x-axis. So we have a vertical stretch by 4. We have K, which is 2. And remember, we're using the reciprocal, so it's actually a horizontal compression of a half. I'm just going to write the word comp. And then we have phase shift. Again, positive symbol, take it out. Minus symbol, minus you're going down or down the graph to the left. And then we're going down 3. Did I? No, I did not. Gotta do the check marks. Don't forget the check marks like I did. Just so you can keep track. Or maybe when you're double checking. Okay, so we have theta, sine theta, or y. Okay, so we have times 4 minus 3. And then we have times half minus pi over 6. So for 0, it's just minus 3 for all the zeros. And then we have a maximum of 1 and a minimum of -7. Okay, so this I didn't really write much down for, but we're going to figure it out. So again, 0 times by a half minus pi over 6 is just minus pi over 6. Okay, so I'm going to do a little bit of freehand work. Pi over 2 times 1 over 2 minus pi over 6. So pi over 2 multiplied by 1 over 2, so it's just pi over 4 minus pi over 6. We're going to create common denominators, and I'm going to use the common denominator of 24, because that's a multiple of 6 and 4. So we're going to do times 4, and we're going to do times 6. So we have 6 pi 24. I'll delete this work when I'm done, so please write it down. Minus 4 pi over 24. 6 minus 4 equals 2 pi over 24. We're going to divide that by 2. 2 is common with 2. Okay, 2 goes into 2 one time. 2 goes into 24 12 times equals pi over 12. Okay, so we're going to circle that. I'll give you 1 moment to pause the video. And now it's deleted. A pi over 12 is too big. And we'll just erase it all. And we'll start from the beginning. So we have pi times a half minus pi over 6. Pi over 2 minus pi over 6. Create common denominators. 6 is a common denominator of 12, so times 3. 3 pi over 6 minus pi over 6 equals 2 pi over 6. We're going to divide top and bottom by 2. 2 goes into 2 one time, strike it out 1. 2 goes into 6 3 times, so it's going to be pi over 3, which is 60 degrees, so pi over 3. So pi becomes pi over 3. I'll give you a moment to write that down. We're just doing it off the top of our heads. So 3 pi over 2. I'm sorry about the equal signs, and we're going to do times a half minus pi over 6. So 3 pi over 4 minus pi over 6. 12 is a multiple, so we don't have to reduce. So I'm going to multiply this by 2. I'm going to multiply this by 3. 9 pi over 12 minus 2 pi over 12 equals 7 pi over 12. And that is correct. I'll give you a moment to write that down. And it's erased. Two pi times half minus pi over 6. Okay, so 2 pi over 2 equals pi minus pi over 6. I'm going to multiply this by 6. 6 pi over 6 minus pi over 6 equals 5 pi over 6. So that's how you find that column there, the x values column. That's how you find the x values column. You mostly have to do it by hand. I'm not sure if there's much online help to help you. I hope that was helpful. And let's get started on our graph. Okay, so because the final transformation graph, is so compressed, I'm gonna have to space out. I'm gonna do no, we have to make sure it's correct, but that's around 15 degrees, that's 60 degrees, and I'm not sure for the rest, but that's okay. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I wonder if I can extend this graph. Okay, let me move things around. And then we're going to move this graph over here. And we're going to extend it. All the way out. And I'm just doing this for spacing reasons for compressed. Because it's 2 in between. I hear an ice cream truck. 1, 2, 3. That's supposed to be there. That's supposed to be there. I'm sorry this is taking so long. Okay, 1, 2, 3, 4. 1, 2, 3, 4. I'm gonna do that and that. 1, 2, 3, 4. 2 pi. So we have, I'm just going to do it by degrees because I know pi over 12 is 15 degrees. And, we also have negative pi over 6, which is negative 30 degrees. So I'm just going to space it weirdly. It's not going to be correct, but it's just for our understanding. Okay, and let's start with our regular sine function. Okay, and then we have pi over 2, pi, 3 pi over 2, and 2 pi. I know it looks slim, but it's just our scale. Then we have 3. Oh, remember, we have negative pi over 6 and negative 3. We have pi over 12 and 1. We have pi over 3 and negative 3. We have 7 pi over 12 and negative 7. And we have 5 pi over 6 and negative 3. So, we have our regular sine function and then our function with all the transformations. And let's do the checklist. Vertical stretch by 4, horizontal comp by half, phase shift left pi over 6, down 3. So, that's our function. That's the end of the video. I have nothing left to teach. And thank you very much for watching. I hope you found this helpful. I hope you found both methods helpful. The list and the chart to help keep track of everything that you're doing. So if you want more videos like this, just let me know. If you have questions, feel free to leave a comment, and thank you very much.